In this video, I want to talk about turn radius, turn rates, and airspeed, in particular all around the central idea of a standard rate turn. Turn coordinators give us an indication of the direction of our turn rate, and the coordination of our turn. The ball that indicates our yaw forces. The turn rate is simply the amount of heading change per time during a turn, and our turn coordinator simplifies this by giving us our turn rate in reference to a standard rate turn. Standard rate turns are used in IFR for timing and traffic separation purposes. On turn coordinators, a standard rate turn notch is shown to the left and right of the artificial aircraft. And sometimes the indicators may even have markings for half standard rate turns or double standard rate turns as well. A standard rate turn is a turn that completes a full 360-degree circle in 2 minutes. This means that in a standard rate turn, your heading changes 3 degrees per second. So to fly a standard rate turn, we simply use our turn coordinator by keeping our white artificial aircraft on the standard rate turn indication throughout the turn. When we do this, we can expect to complete the full 360-degree circle in 2 minutes. Here we show a standard rate turn to the right with our turn coordinator indicating standard rate and our turn finishing in 2 minutes. Now we show a standard rate turn to the left with our turn coordinator now indicating a left standard rate and our left turn circle finishing in 2 minutes. The FAA written may ask you some timing questions that revolve around standard rate turns. For example, they may ask you how long it will take in a standard rate turn to turn from a heading of 015 degrees to 195 degrees. This would be a total heading change of 180 or 180 degrees. If we just remember that a standard rate turn is 3 degrees per second, we can use this information as a starting point to determine the answer. We simply divide 180 degrees, which is our total change of heading, by 3 degrees per second to get 180 divided by 3 equals 60 seconds or 1 minute. So it would take you 1 minute to turn from 015 to 195, or a turn of 180 degrees when turning at the standard rate. You can do the same sort of simple math if they ask you how long it would take to do slower than standard rate turn or faster than standard rate turn. For example, if they ask you how long it will take to make a complete circle at 2 times the standard rate, then if we start with the knowledge that a standard rate is 3 degrees per second, then 2 times faster than that would be 6 degrees per second. So we divide the degrees in a complete circle, 360 degrees, by 6 to get 60 seconds to complete a first full circle at 2 times the rate of a standard rate turn. To increase or decrease your rate of turn, you will need to adjust your airspeed and your bank angle. To increase your rate of turn, you need to slow your airspeed and increase your bank angle. The steeper your bank, the greater your rate of turn, and the slower your airspeed. The greater you can increase your bank. Decreasing your rate of turn is just the opposite. Another thing to consider is the turn radius. Your turn radius increases when you have a higher airspeed and slower rate of turn. This means you will need a larger airspace to turn in, and this is important to know for approaches and holding patterns that want you to stay within a protected area of airspace. The opposite is of course true when you have a slower airspeed, higher bank angle, and thus a higher rate of turn. In this scenario, your turn radius and the airspace you cover in your turn is much smaller. Let's visualize this first with a standard rate turn to the left at about 93 knots of airspeed. Here we maintain 93 knots on our airspeed indicator and standard rate on our turn coordinator and complete a 360-degree circle in 2 minutes with a constant turn radius. Now, let's say we wanted to increase our turn rate and complete our complete circle in half the time. This would be 2 times the standard rate turn and would allow us to complete a complete circle in 1 minute instead of 2 minutes. To do this, we would need to increase our bank angle and decrease our airspeed, as you see here. When this happens, our turn radius decreases as we have a tighter turn and it takes up less airspace during the turn. Finally, let's say we want to decrease our turn rate and complete our circle in twice the time. This would be half the standard rate turn and would allow us to complete a complete circle in 4 minutes instead of 2, as in the standard rate. To do this, we would need to decrease our bank angle and increase our airspeed, as we see here. When this happens, our turn radius increases as we have a looser turn that takes up more airspace during our turn than we would have in a standard rate. There is a side effect of changing our bank angle and our turn radius in that when we do that, we change airspeeds, and that changes the amount of lift that we are creating. So let's do an example. In this example, we increase our bank angle to increase our turn radius. This decreases our airspeed and we get less lift over our wings. This less lift, as you can see, drops our aircraft and we will lose altitude in our turn. So therefore, as we can see on the attitude indicator, what we need to do is actually pitch up when we tighten our turn in order to increase our angle of attack to get that extra lift in order to maintain our altitude.